Hey friends, for those of you that were at the junior class meeting while we were going over this, or just weren't at school yesterday, or today, I wanted to just go through some of these examples together so that you know exactly what I want you to do. So, notice this coordinate here. We've got 5, -12, okay? Usually, we've trained ourselves to think that cosine is x and sine is y. But that is only true when you are on the unit circle. Well, if you look on your unit circle, 5 -12 is nowhere to be found. So in this scenario, what we have to do is make sure that we actually draw our triangle. So if we thought about actually plotting the point, so that's hint number 1. Plot your point. If you actually thought about it, we would go right 5, we would go down 12. So this would be your 5, this would be your -12, and that would be your point. Well, if you actually trace your path, you automatically make a right angle. Well, if you connect this straight to the origin, you have a perfect right triangle, and we always use the angle by the origin. Now, to find your missing side, you can do Pythagorean theorem. So that would be 5 squared plus -12 squared equals c squared. So c is going to end up equaling 13 when you do that math. Okay? Now, one thing, if you're using your calculator to help you with this, if you do not put your negative in parentheses like I did here, it will not give you the right answer. So you've got to make sure negative numbers have parentheses around them. But once you do that, the rest is easy. It's SOHCAHTOA. That's all it is. You just got to draw the triangle so you know your side lengths. Then you can do SOHCAHTOA, or, our hippies. Talk about them instead. So that means that sine would be opposite over hypotenuse. So sine would be -12 over 13. Cosine would be 5 over 13. And tangent would be -12 over 5. Then to do our reciprocals, we just flip them. So cosecant would be 13 over -12. Secant would be 13 over 5. And cotangent would be 5 over -12. That is all this is. Now, if we go to our next page, if I remember how to do this, we have another one. So let's try this one. Okay? So we're going to do the same thing. We're going to start by drawing our triangle. This time it's -3, 4. So that means we're going to go left 3, up 4. So there's my -3, there's my 4, there's my right angle. The only way I can make that a triangle is to connect it to the origin. And my angle is always the one by the origin. So to find my missing side, we've got -3 squared plus 4 squared equals c squared. When you do that, you'll get 25, and when you square root it, you get c equals 5. Then the rest is just SOHCAHTOA. Sine would be 4/5. Cosine would be -3/5. Tangent would be 4 over -3. Then you flip them. 5 over 4, -5 over 3, and -3 over 4. It is that easy. The one thing is make sure that you always watch, misspelled, watch your positives and negatives. Okay? I've emphasized this a lot. But remember, all students take calculus that we talked about. We're in quadrant 2. So the only thing positive should be sine and its reciprocal. So check. Sine is positive. Cosine and tangent are both negative. Cosecant, which matches sine, is positive, and secant and cotangent are negative. So this is why I keep stressing to check your signs. Okay? Now let's look at the last one I got up here. And this one I already have done for you, so we'll just talk through it. This one, it was -2, -3. So this time, when you did your Pythagorean theorem, which I have all the work shown to you out here, okay, notice it's a little different because you don't get a perfect square when you add your -2 squared and your 3 squared together. You get 13. I do not want decimals. I want you to leave them as radicals, okay? But I want you to always make sure you reduce your radicals. I want you to always reduce your fractions and always rationalize. Those are the things you always have to make sure you're doing, okay? Square root of 13 doesn't reduce. There's no perfect square that is a factor of 13. So we can go straight in here and start doing our sine, our cosine, and our tangent. And that's just SOHCAHTOA. Now, when you flip, okay, please make sure to make a note to not flip the ones that you've already rationalized, okay? Notice to flip, I took what I originally wrote down and I flipped it. Same thing here, and I flipped it. I didn't flip the rationalized ones because if I do that, I'm going to have to re-rationalize and I'm going to have to reduce my fraction. That's too much work. So always flip the ones that aren't rationalized because it will make your life a lot easier and make it fewer mistakes. Okay? Y'all, this is the only other new concept we have really for this unit for right now. And so that's why I wanted to go ahead and show it to you. A few reminders about reducing radicals. If you want to reduce a radical, so let's just take square root of 8. Remember, you're coming up with perfect squares that go into 8. So you could take a calculator and just start dividing them if you didn't know. And your perfect squares are your 4, your 9, your 16, your 25. Well, hopefully we all know that 8 is 4 times 2. Well, when you square root something that's been multiplied together, which all we did was rewrite 8 as multiplication, you square root each piece individually. Square root of 4 is 2, and square root of 2 we can't do anything with. So square root of 8 is square root of 2, 2 root 2. This is what I want you to use. That is reduced form. So if you had square root of 27, 9 goes into 27, and 9 is a perfect square. So 9 times 3. Square root of 9 is 3, root 3. On one of your worksheets, you actually have square root of 80. Well, square root of 80, maybe you don't know that 16 goes into 80. Maybe you think of 4 first. If you do that, 4 times 20 might be the first thing that comes to your mind, and that's okay. Because you can reduce that. You get 2 times square root of 20. But square root of 20, that still reduces. So just make sure when you've reduced all the way. Because square root of 20 is also 4 times 5. Well, square root of 2 is 2. You already have a 2 outside, so that's going to make it a 4 times square root of 5. Okay? Then if you were rationalizing with something like this, you would only multiply the top and the bottom by the square root of 5. You wouldn't have to use the 4, just the square root. Well, I hope this helped with anything that you missed today. And if it didn't, we can go over anything else we need to on Thursday in class. Thanks, y'all. Have a great day. Love ya.